Everybody, welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and in this class we are going to learn how to represent irrational numbers on the number line, and also we are going to do rationalization of denominator. So I hope you guys are ready. Just comment in the chat over here. Just let me know if you guys are there and you are ready for this thing. Okay. So we are going to do rationalization of denominator and representation of irrational numbers on the number line. In the previous session, we have studied the decimal representation of real numbers. So we already know that for rational numbers, there can be two types of decimal representation. Either it can be terminating decimal representation or it can be non-terminating but repeating or recurring decimal representation. And for irrational numbers, only one type of decimal representation is there, that is non-terminating and non-repeating, or you can say non-terminating and non-recurring decimal representation. So these are the two types of things which we have done in the previous session, and we have also learned in the previous session that how to represent the bar form of numbers. We have studied bar form, that is vinculum form of numbers, for example 0.9 and a bar over it, to represent it in the form of p by q, where p and q are integers and q is not equal to 0. Hi Shanu, hello Sakshi, welcome to this session. Now in this session we are going to learn how to represent irrational numbers on the number line, and also we'll learn the rationalization of denominators over here. So are you guys ready? Just comment in the chat. Just let me know if you guys are ready over here. Hello Sakshi, hi Shanu, good evening, welcome to this session. Good evening Mahinder, welcome to this session. So are you guys ready? Okay Ashwarya, very good. So let's start with this session guys. So basically first thing which we need to know over here is every real number is represented by a unique point on the number line. Also every point on the number line represents a unique real number. Basically, if you take the number line, right, if you make the number line over here, so for example, you have got 1 and 2 on the number line. So you see on the number line, infinite number of points are there between 1 and 2, right? Infinite number of points are there between 1 and 2 on the number line. You cannot count them, right? So every point on the real number line will represent a real number, and every real number will represent a point on the real number line. So in both the ways it is true. So is it clear to everybody over here? A very basic doubt. Yes. Yes, Mayuk. Okay, Shanu. So just let me know that quickly guys. If I'm explaining something, just comment with that quickly so that I can know that if it is clear to you or not. Very basic concept over here. Right? So is it clear? Sakshi, Shanu, Mahinder, Ashwarya, Mayuk. Okay. Now basically over here we are going to represent irrational numbers on the number lines. Representation of rational numbers you already know. We want to understand the representation of irrational numbers on the number line. So basically we can do it using Pythagoras theorem, right? So for that let's revise the Pythagoras theorem. If you have got a right angle triangle, this is 90 degree. So this is the base, this is the perpendicular, and this is the hypotenuse. The side opposite to the right angle is called the hypotenuse. So according to the Pythagoras theorem, hypotenuse square is equal to sum of the squares of the other two sides, right? This is the Pythagoras theorem. So basically we'll be using Pythagoras theorem to represent root 2 on the number line, right? So if you make a right angled triangle like this, you see over here. Suppose this is of 1 unit and this is of 1 unit, and suppose the hypotenuse is of x units, right? So we can use the Pythagoras theorem over here. The side opposite to the right angle is the hypotenuse. So the hypotenuse square is equal to the sum of the squares of the other two sides, right? So that is equal to 2 over here. Although this will give you two values because this is a quadratic equation. You will study about it in grade 10. This will give you two values of x. But over here we'll neglect the negative value and we'll take the positive value only because distance cannot be negative. So you can say that the hypotenuse over here will come out to be equal to root 2. So we can use this concept to represent root 2 on the number line, right? So how we can do that? See, you have got the number line over here, this is 0, and obviously 1 unit away from it is the real number 1. Now at this point 1, can we drop a perpendicular, guys? At this point 1, we can drop a perpendicular of 1 unit distance, right? So we have done that. So this is 90 degree. So guys, if you will join this thing, can we not say that this will come out to be equal to root 2 units only? Because that we have proved right now over here. So what you need to do, you have to take this root 2 distance, you have to take it on the number line. You have to transform this root 2 distance on the number line over here. So how you will be able to do that? Tell me. You will put the needle of the compass at this point and the pencil at this point, right? And then you can take this arc over here. So what will happen? This distance on the number line will be equal to root 2 only, and this point will show root 2 on the number line. So is it clear that how we can show root 2 on the real number line? Is it clear, Sakshi, Shanu, Mahinder, Ashwarya, Mayuk? Any doubt in this thing to everybody, to any student over here, guys? So that's how you can represent root 2 on the real number line. It's a very simple thing. If you understand the Pythagoras theorem, you can easily do it. Right. Okay. Now in the same manner over here, if you have got root 3, how you can represent root 3 on the number line? So it's again a very simple thing. See, you have got a right angle triangle. Suppose this is 90 degree over here, obviously. So over here, guys, if I take, suppose, if I take this to be root 2 over here, right? And if I take this to be 1, so what is the value of this hypotenuse? You can use the Pythagoras theorem. Hypotenuse square is equal to root 2 square over here plus 1 square, right? Root 2 square is 2 only. So this is 2 plus 1, 3 or not. So again you will get the hypotenuse to be equal to plus minus root 3. 2 roots you will get over here, right? Because it is square over here. So you will get 2 values, right? So one value you will neglect because distance can never be negative. So I will take y is equal to square root of 3. So basically you have got a right angle triangle in which if one side is equal to root 2 units and one side is equal to 1 unit, so the hypotenuse will automatically be equal to root 3 units. So what happens over here? In order to plot root 3, you must know how to plot root 2. You can automatically do that. So you see over here, basically we have got this to be root 2, this thing to be root 2 over here. Now can I make 1 unit perpendicular on this point? Tell me. I can make 1 unit perpendicular over here. So can I not say that this thing will be equal to root 3 only if you join it with the O over here? So this will be root 3 or not? Tell me, guys. Using the Pythagoras theorem, because this is root 2, this is 1. So this thing will automatically be root 3 units or not? Tell me. So what you will do? You will put the needle of the compass at this point and pencil at this point, and you will transform it on the number line or not? Tell me. So basically this distance will come out to be equal to root 3 units, and this point on the number line will show root 3 on the number line. Is it clear to everybody over here? Using the Pythagoras theorem, Ashwarya, see, I have proved it, that's why over here, you see, if you take one side to be root 2 and other side to be 1, so over here if you want to find the hypotenuse, you see, will you not get root 3 over here, Ashwarya? Tell me. It will come with practice. Is it clear to you or not, Ashwarya? Yes or no? Just confirm in the chat, guys. Is it clear to everybody in this session? Shanu, Mahinder, Ashwarya, Mayuk, Sakshi. Exactly. It depends on the question. Actually, there is one more method as well. I'll explain that as well. Don't bother. I'll explain that as well. Okay. Now you have got this square root spiral basically. How will you make a square root spiral? So basically this is a question in NCERT, it is given. It's not a very big deal. I'll explain the square root spiral to you. So see what is happening over here. If you make the number line over here, suppose this is the origin, or you can say 0, 1 unit distance it is. At this point you've dropped 1 unit perpendicular, right? So using the Pythagoras theorem, this was coming out to be equal to root 2 units or not? Tell me. This was coming out to be equal to root 2 units. Now again if I drop 1 unit perpendicular at this point, Can I not say that this was coming out to be root 3 units? Tell me. This was coming out to be root 3 units. Now tell me guys, if I drop 1 unit perpendicular over here, will I get square root of root 4 over here? Tell me. If you drop 1 unit perpendicular, it will give you square root of 4 or not, using the Pythagoras theorem. So what does it mean? You can keep on dropping 1 unit perpendicular over here. You will get square root of 5. This will be square root of 5. In the same manner, you can keep on dropping 1 unit perpendicular. This will be square root of 6. So basically what you are getting? You are getting a square root spiral or not? What is the meaning of spiral? Spiral is something like this or not? So this is coming out to be a square root spiral or not? Tell me guys. So is it clear that what is the meaning of square root spiral? You can keep on dropping 1 unit perpendicular, and every time you can use the Pythagoras theorem. You will get the square root of consecutive natural numbers, one after the other natural numbers you will get over here, and square root of them. Is it clear to every student in this session? Tell me guys. Any doubt in that? Just confirm that quickly in the chat so that we can move on to the next thing. Now basically there is one more method by which you can represent square root of square root on the number lines. I'll explain that, right? So for example, you want to show over here anything square root of x on the number line. Anything it can be. It can be suppose square root of 10, it can be anything, square root of 9.8, it can be square root of 17, square root of any rational number obviously on the number line. If you want to show, how will you show that? So there is a method of showing that, okay? And this method you must remember, there is a proof to it as well. I'll explain the proof as well. First you need to understand the methodology involved, that how will you actually do that. So for example, I'm just taking anything, square root of x, I'm taking the general example over here, right? Square root of x over here. So what will I do? The very first thing is to make x units over here. So you will make x units over here, right? X units, whatever it can be. X can be anything, 10, 9.8, 17, anything. So you have made x unit distance. Now what you will do? From this point, extend it to 1 unit extra, okay? From this point, extend it to 1 unit extra. You got it, I think, right? Now what you will do? Suppose this is A, and this point is B, and this point is C. Now you have to make the perpendicular bisector of AC. I hope you remember how to make perpendicular bisector. So perpendicular bisector of AC will be somewhat like this. Guys, obviously this is not perfect because I'm just making a rough figure. So you have to make the perpendicular bisector of AC. Suppose its midpoint is anything, suppose D. Okay? Something like this. Now you can take D as the center and AD as the radius or DC as the radius. They both are equal only. You can take D as the center and then AD as the radius or DC as the radius, because AD and DC they are equal only, and then you can make a semicircle. So you'll make a semicircle like this. I hope it is clear, right? Now from the point from which you have extended 1 unit extra, drop a perpendicular on that point. Drop a perpendicular at that point. I hope you got it. I hope this thing is clear to everybody. So what you will see guys, that this thing will come out to be equal to square root of x. This distance is equal to square root of x. Yes, I will repeat it deep into God. Just let me explain it for the first time, right? So from this thing, this will be square root of x. So basically what you need to do, you need to take it on the number line. You need to take this distance on the number line. That's what you needed to do in the first place, right? So what will you do? You'll put the needle of the compass at this point and then take this distance and take it on the number line. So on the number line, basically this distance will show square root of x. This distance will show square root of x on the number line, and over here B is the origin, because you want to show root x on the number line. So if you consider B as the origin, this point will show root x on the number line. Is the method clear to everybody? Now once again I will repeat it deep into God. This is there in your syllabus, just try to understand that this is very important. So what you are doing, we have to show square root of x on the number line. So the very first thing is to make x units, draw x units over here. Now from point B, suppose you have named it A and B. From B, just extend 1 units extra. So 1 units extra you have extended, right? Now you can make the perpendicular bisector of AC. Perpendicular bisector of AC you have made. I hope that is clear to you. Now you can take D as the center and you can take AD as the radius or DC as the radius. AD and DC, they are equal only. You can make a semicircle then. Now the point from which you have extended 1 unit extra, at that point you have to make a perpendicular. I hope that is clear to you, right? So basically this distance will come out to be square root of x. This distance will come out to be equal to x square root of x. So what you have to do? You have to take this distance and you have to transform it on the number line. That's it. So put the needle of the compass at this point, take this distance, take it on the number line. So basically this distance is representing root x on the number line, and obviously you have to take point B as the origin. Not origin, you can say 0. And obviously this point will represent root x on the number line. Is it clear to everybody over here? Deep into God, Aditya, is it clear? Mahinder, Shanu, Mayuk, is it clear to everybody in this session? Tell me. So it's not a very big deal over here. Now there is a proof to it as well, that why this is actually working. You must know the proof as well, na? That why this is coming out to be square root of x in the first place. You must know the reason as well. So I'll explain the reason as well. It is not a big deal. See. So for that, what I will do over here is I will join this. I will have to join this. Okay. I have to find this na. Suppose this is y. Okay. Suppose this thing is y. Now you see over here, AC is the diameter of the semicircle or not. See it very patiently. AC is the diameter of the semicircle. And AC is what? Just see the figure. AC is equal to x plus 1 or not. AC is equal to x plus 1. So the radius of the semicircle is x plus 1 by 2 or not. Tell me. Radius of the semicircle over here is x plus 1 by 2. Now you see this is also the radius of the same semicircle. So can I not say that this thing is equal to x plus 1 by 2 as well? This is equal to x plus 1 by 2. Now you see radius of the semicircle is DC. You see over here DC. I have to find dB. What is dB over here? dB is equal to DC minus 1 or not. See the figure. DC minus 1 is equal to dB. And DC is what? DC is a radius of the semicircle. And radius we have already got, that is x plus 1 by 2 minus 1. If you simplify, you will get x minus 1 by 2 over here. So what does it mean? That this thing dB is coming out to be x minus 1 by 2. I hope this is clear to everybody over here, up till here, right? Now basically I have to find y over here. Now this is a right angled triangle or not, in which this is the hypotenuse. So you can use the Pythagoras theorem, right? Hypotenuse square, that is x plus 1 by 2 the whole square, is equal to sum of the squares of the other two sides. So y square plus this thing, x minus 1 the whole square, x minus 1 the whole by 2 the whole square, and you have to find the value of y. So let us find the value of y. It's not a big deal. So you see this will be equal to x plus 1 by 2 the whole square minus x minus 1 by 2 the whole square. You can simplify it further. You will get x plus 1 by x plus 1 the whole square minus x minus 1 the whole square. And in the denominator 2 square is 4 only, that was already given there. Now I can further simplify it. Just simplify the numerator over here. You will get x square plus 2x plus 1. You can use a plus b the whole square formula minus x square plus 2x plus 1. You can use minus 1 divided by 4. You can do this calculation, guys. This will get cancelled out. This will get cancelled out. So basically you will be left with 4x by 4 after simplification, and that is equal to x only. So basically you will get y square is equal to x. So y square is equal to x is coming. What does it mean? That y will be square root of x or not. We are neglecting the negative value. Y is equal to square root of x. That is the proof. We needed to prove that this thing is equal to square root of x. Is this clear to everybody in this session? Deep into God. Mahinder, Aditya Singh, Ashwarya, is it clear? Mayuk, any doubt in the proof of this? That why this is equal to square root of x over here? Why y is equal to square root of x over here? So you must know the method as well, you must know the proof as well. Maybe this will not be asked in your school examination, but you must know it. Please understand that you must know it. Okay, so let's move on to the next thing. So that was all which you need to learn in how to represent irrational numbers on the number line, right? Now we have got something called rationalization of the denominator. So let us learn that. Basically, the first question is, why do we actually rationalize the denominator? See, for example, I've got a number like this. The denominator is an irrational number. Root 5 is an irrational number. So the question is, why will you rationalize the denominator? Because if the denominator is an irrational number, you cannot divide it. You cannot estimate its value. Can you do that? Tell me. You cannot estimate its value, na? You cannot do this type of division. Can you do like this? Tell me. Can you do this type of division? It is not possible. So therefore, you have to rationalize the denominator so that you can estimate its value properly, right? So how will you rationalize? Basically, you have to make the denominator a rational number. That is the meaning of rationalization. So over here it is root 5. So it means I have to multiply by root 5 in the denominator as well as the numerator. Why I am multiplying by root 5? Because root 5 into root 5 will give you square root of 5 the whole square. See, this will be 3 root 5 and in the denominator it is square root of 5 the whole square. And you know that square root of 5 the whole square will be 5 only. You got it? So that is the rationalized form over here. So basically you multiply this by a rationalizing factor of it. Over here root 5 is a rationalizing factor of root 5. There can be infinite rationalizing factors of root 5, because any number by which you multiply root 5, and if you are getting a rational number as a product, so that number will be called a rationalizing factor of root 5 over here. So now you can easily at least predict its value, right? Because what will happen? You see 5 6 are 30, so at least you can do 0.6, and you know that up till some places of decimal you can find the value of square root, na? Up till some places of decimal you can find the value of square root 5. You got it? But if it is given in the denominator, it will be very tough for you to estimate its value. So that is the reason of doing rationalization, and obviously many a times it is used in simplification in case of questions. So I hope it is clear. Now this was a very simple thing. Now every time you will not get rationalization like this. For example, I have got, I am making a question on my own. You can also make it a simple thing. Suppose I have got this. So can you rationalize the denominator in this case? What will you get? 3 upon root 12 minus root 9. So every time this trick will not work, na? Every time this will not work. So you have to use this different type of formula. Okay, Deepanjan. You have to use different type of formula over there, right? So basically what will I do? See, this is of the form a minus b. You know this identity, you have studied since childhood. A square minus b square, I think since grade 7. A square minus b square is a plus b into a minus b, right? This formula you have studied. So basically I will try to fix the denominator in that form only. It is given of the form a minus b. So I will multiply and divide by a plus b, square root of 12 plus root 9. And over here as well you have to do that, square root of 12 plus root 9. Can I do something like this? Tell me guys. So basically what will happen? The numerator is square root 3 into square root of 12 plus root 9, and in the denominator it is of the form a plus b, a minus b. So the denominator will give you a square minus b square. So root 12 square minus root 9 square over here. I hope that is clear to everybody over here. So that will give you 3 into root 12 plus root 9, and in the denominator what is it guys? Root 12 square is 12, root 9 square is 9. So that is basically 3 only in the denominator. So this will get cancelled out. Now don't leave the answer in that form, you can further simplify, because square root of 12 can be written as square root of 4 into 3 and square root of 9 can be written as only 3. And you see this is 4. So 1, 2 will come out of the square root. So it is 2 root 3 plus 3. This is the answer after rationalizing the denominator of this thing. Is it clear to everybody? Ashwarya, Deep into God, Mahinder, Aditya Singh, Mayuk, Deepanjan. So guys, please confirm in the chat everybody and keep on writing in the chat if it is clear to you. Because if you will not comment upon that, I will not be able to understand if you are understanding it or not. Is it clear to everybody there in this session? Tell me guys. Okay David, so please confirm that, okay, Ashwarya. So it's a simple thing over here, but it is a very important thing. One of the important things in mathematics. Okay Aditya. Let's move on to the next thing. You can try doing questions over here, concepts I have already explained. So can you find the value of this? If a is equal to 1 plus root 7, can you find the value of minus 6 upon a? Try doing this and let me know the answer over here. A is equal to 1 plus root 7, you have to find the value of minus 6 upon a. So over here you just need to put the value, just put the value of it guys. This is minus 6 upon a. So it is minus 6 upon a is what? 1 plus root 7. So needless to say, it is not mentioned in the question, but you have to rationalize the denominator, right? That is not given in the question because you cannot leave it like this. So basically it is 1 plus root 7, I have to multiply and divide by 1 minus root 7, right? Then only you will be able to fix it in the identity. So minus 6 into 1 minus root 7, and in the denominator it is of the form a plus b, a minus b. So it will give you a square minus b square. So 1 square minus root 7 the whole square. So it is minus 6 into 1 minus root 7, and in the denominator this is 1, root 7 square is 7. So basically what it will give you guys, minus 6 into 1 minus root 7, and in the denominator it is minus 6. So this will get cancelled out. So basically you are getting 1 minus root 7 in the answer. Is it clear to everybody? Very good Ashwarya, that is correct. I hope it is clear. So it is one of the basic questions which you can get, but again it is very important. Is it clear to every student over here in this session? Mayuk, Aditya Singh, Ashwarya, okay, you already got the answer. Deepanjan, David, why you guys not doing the question, right? So let's move on to the next one. So can we do these questions one by one? So the first part over here is you have to find the value of x plus 1 by x. X is given 9 minus 4 root 5, then you have to find the value of x plus 1 by x and x minus 1 by x over here. Try doing it guys. So over here what you have to do, you see the value of x we already know. So we have to find the value of 1 by x first. So 1 by x will be 1 by 9 minus 4 root 5, right? 1 by 9 minus 4 root 5. So needless to say you have to rationalize the denominator over here. So you have to multiply and divide by 9 plus 4 root 5. I hope it is clear. 9 plus 4 root 5. So you see the numerator over here is 9 plus 4 root 5, and in the denominator it is automatically of the form a plus b, a minus b. So it will be a square minus b square. So that will be 9 square minus 4 root 5 the whole square, right? Something like this it is coming up. Now this is 9 plus 4 root 5. Now you see in the denominator 9 square is 81, 9 square is 81, and 4 root 5 square is what? See, 4 square is 16 and root 5 square is 5. So 16 5s are 80. So basically 1 is there in the denominator. So 1 by x is 9 plus 4 root 5 only. This is 9 plus 4 root 5. So the first part of the question is we have to find the value of x plus 1 by x. So x is already 9 minus 4 root 5. And the value of 1 by x we have got to be equal to 9 plus 4 root 5. So that is what we are getting. So you see we can cancel out this. So x plus 1 by x is 9 2s are 18. First part of the question is 18. Very good, Aishwarya. And what about the second part over here? Second part also you can find. X we already know over here. X is equal to 9 minus 4 root 5 and minus of 1 by x is 9 plus 4 root 5. So this is 9 plus 4 root 5 over here. So let us simplify it. Open up the bracket, you will get 9 minus 4 root 5 minus 9 minus 4 root 5. So over here this will be cancelled out and your answer will be minus 8 root 5. So minus 8 root 5 is the answer. Very good. I hope that is clear to every student over here. Just confirm in the chat if it is clear or not. Aditya, Mayuk, Deepanjan, Aishwarya, David, is it clear to everybody else over here? Okay, Aditya, you already got the first part. Second part also you can get easily over here. I hope that is clear to everybody. Okay. So let's move on to the next thing over here. Can you try doing this one? You have to find the value of a if this thing is given to be equal to this thing. If 6 minus 3 root 2, 6 divided by 3 root 2 minus 2 root 3 is equal to 3 root 2 plus minus a root 3. So you can try this orally as well. If you can try doing it, actually you can do it orally. It's not like these are not very tough questions. I'm saying that only. So try doing this, guys, if you can do. Find the value of a if 6 divided by 3 root 2 minus 2 root 3 is this thing. So basically again over here if you take the left hand side, what you can do, can you not rationalize the denominator in the left hand side? You see this is 6 divided by 3 root 2 minus 2 root 3. So what does it mean? You have to multiply and divide by 3 root 2 plus 2 root 3. You have to change this sign over here or not? Tell me. 3 root 2 plus 2 root 3. So over here it is 3 root 2 plus 2 root 3 over here, right? So what I can do, that is equal to nothing but 6 into 3 root 2 plus 2 root 3, and in the denominator it is of the form a plus b, a minus b, right? A minus b, a plus b, so it will be a square minus b square over here. So it will be 3 root 2 the whole square minus 2 root 3 the whole square. Something like this you'll get over here. So if you further simplify, this is 6 into 3 root 2 plus 2 root 3. And basically in the denominator what you will get, guys, see this is 3 3s are 9 because square of it 3 3s are 9 and root 2 square is 2. So 9 2s are 18 is coming up. And over here 2 2s are 4, root 3 square is 3. So 4 3s are 12 is coming up basically. So what we are getting, guys, 6 divided by 8 minus 12. 8 minus 12 is 6 only. So this will get cancelled out or not. So basically this thing is equal to 3 root 2 plus 2 root 3 only. 3 root 2 plus 2 root 3 only, right? And this thing is given to be equal to 3 root 2 minus a root 3. 3 root 2 minus a root 3. So if you will compare, what will be the answer? Basically this is equal to 3 root 2 minus a root 3 over here. So if you will cancel out this and then you will get 2 root 3, that is equal to minus a root 3 over here. So this will get cancelled out. So basically a is coming out to be minus 2. So the answer over here is a is equal to minus 2. Is it clear to every student over here? Tell me. Is it clear, Aishwarya, Aditya, David, Deepanjan? Any doubt in the question, guys? Okay, so let's move on to the next one. Okay, very good. So can you do this one? If p is given to be equal to 5 minus 2 root 6, can you find the value of p square plus 1 by p square over here? Can you find the value of p square plus 1 by p square? Try doing it and let me know the answer over here, guys. Root is the sign of multiplication. Root is the sign of multiplication. Not able to understand your question, Bimla? Root is the sign of multiplication. Not able to understand that, Bimla? What are you trying to ask? Can you rephrase your question once? So over here we have to find the value of p square plus 1 by p square. So basically p is already given. Can we find the value of 1 by p? So 1 by p will be 1 by 5 minus 2 root 6 over here. So we can rationalize the denominator over here by multiplying and dividing by 5 plus 2 root 6. By multiplying and dividing by 5 plus 2 root 6 over here. So basically you see in the denominator, in the numerator it is of the form 5 plus 2 root 6, and in the denominator it is of the form a minus b, a plus b. So it will be a square minus b square. So it will be 5 square minus 2 root 6 the whole square over here, right? So basically over here 5 5s are 25, right? And 2 2s are 4 and root 6 square is 6. So 4 6 are 24. You can do that in your mind. So this is 25 minus 24. So basically 1 is coming in the denominator. 5 plus 2 root 6 is there. 1 by p is 5 plus 2 root 6, correct? Let's see that if it is correct or not, Abu and David. So we have to find the value of p square plus 1 by p square. So p square means 5 minus 2 root 6 the whole square. And 1 by p square is what? This is 5 plus 2 root 6 the whole square. Yes, so it is something like this. So you can just open up the bracket, you will get the answer. You can use a minus b the whole square formula over here. So you will get 5 square minus 2 into 5 into 2 root 6 plus 2 root 6 the whole square, correct? In the same manner you can use a plus b the whole square formula over here. So you will get 5 plus 2 into 5 into 2 root 6 plus 2 root 6 the whole square. I hope that is clear. So you see this thing and this thing will get cancelled out over here, and the answer will be what? 5 5s are 25, and this is basically what? 2 2s are 4. 2 square is 4, root 6 square is 6. So 4 6s are 24. So this is basically 24. In the same manner you will get 25 plus 24. So your answer will be what over here? This is 50 and 48. 50 and 48 is 98. So 98 is the correct answer. Very good, David. Is it clear to every student in this session? Exactly, Abu. I hope it is clear. What happened to you, Aishwarya and Aditya? Why are you guys not doing questions? I hope it is clear to everybody in this session. Okay. Okay, very good. Let's move on to the next one. So you see, if root 3 is given to you 1.732, can you find the value of 2 upon root 3 minus 1 over here? 2 upon root 3 minus 1. So you see, this question is given just to make you do rationalization of denominator. If you will actually put the value of root 3 over here, it will be a very big calculation. It will be an unnecessary wastage of time. You got it? So for that purpose only, this question is given, so that you can use the concept of rationalization of denominator. Over here, if you will directly put root 3 is equal to 1.732, it's going to waste your time. So what we can do, before putting the value of root 3 over here, we can rationalize the denominator. This is root 3 minus 1. So I can multiply and divide by root 3 plus 1 over here, right? Multiply and divide by root 3 plus 1. So basically in the numerator you will get 2 into root 3 plus 1, and in the denominator it is of the form a plus b, a minus b. So that will be a square minus b square. So it will be basically root 3 square minus 1 square. So it will give you what? 2 into root 3 plus 1, and in the denominator you can get root 3 square is 3 minus 1, that is 2. So basically the answer is equal to root 3 plus 1. So now you can easily put the value of root 3 which is given to you. The value of root 3 is 1.732, which you have to take, plus 1. So basically the answer is 2.732. Although you can never get the exact value of root 3, that is an irrational number. So nobody in this world will be able to find the exact value of any irrational number, right? But this is just an approximate value and you have to work according to the question. Very good, that is correct, Aishwarya and Abu. I hope that is clear to every student over here. So that's all we needed to do in this class, guys. In the next class, we'll be doing laws of exponents and we'll be practicing many more questions on the basis of those concepts. Please don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And also don't forget to subscribe to the Telegram channel. The link of it is given in the description below. Bye bye guys. See you then in the next class. Take care everybody.